Hi, everyone. I'm Mine Dogucu. I'm an associate professor of teaching and vice chair of undergraduate studies in the Department of Statistics at University of California, Irvine. And
I'm Mine Çetinkaya-Rundel. I am a professor of the practice and the director of undergraduate studies in the statistical science department at Duke University.
I will answer the question that everybody has on their mind. What are the chances of having 2 minutes give a talk at the same time? I actually don't know, but I'll give you one statistic that can help you calculate the chances. So Mine and I are both originally from Turkey, and Mine is the 126th most common name in Turkey. So that can help with your estimation. So thank you, Mark, for inviting us. When Mark invited us, he asked if he would present this paper Mine and I collaborated on, Tools and Recommendations for Reproducible Teaching. It was published in JSDSC back in 2022, but as you know, the publication process, this was actually written in 2021. So, and you all know how fast the computing scenes can change over the years. So it's been about 3 years since this paper has been updated. So during this talk, we'll use the general ideas in the paper, but we have updated our examples for this specific talk. So I think many of us who are here, we have two hats. We are teachers, but we're also scholars. So we have our research side and teaching side at the same time. So I want you to imagine a teacher scholar who has this set of toolkit. So for their research, this teacher scholar, because this is their scholar side, they might perhaps be using R for their research. And when I say R, this is the R ecosystem that can include version control as well, if they wanted to, but Quarto and so forth. And for their teaching, they might be producing perhaps slides, so they might be possibly using PowerPoint for that. But then they also have something that they teach to their students, which perhaps maybe is a graphing calculator. This is not to say these are good examples, but I'm just trying to differentiate the dimensions of tools that we have. We have tools for research, we have tools for teaching, and we have tools for learning. Of course, this teacher scholar can also be using R across the board for research, teaching, and learning. So you have heard from our colleagues here today talking about their research, teaching reproducible research. Perhaps we've heard about the learning side too. What do students learn? But Mine and I actually focus on the second dimension, the teaching part. So what is the instructor using as an instructor themselves, not as a researcher outside, or what they teach to their students, but what they use to prepare their teaching materials. So why is reproducible teaching important? First and foremost, especially in Mine's and my cases, we teach hundreds of students in our courses, and that means a lot of files, and course management has to be in some organized manner for us to be able to manage all these large files together. And I think this is a trend across in many universities, a larger enrollment of stats and data science courses. So this is actually becoming even more important for us to be able to manage these as instructors. Another reason that it's important for us to teach reproducibly is because students see us. Like, I'll give you one example. I'm that instructor who always has some typo in the slides. I actually, in the middle of class, I would directly go to my Quarto slides, and live students would see me fixing it. If this is a class where I also teach Quarto to them, this is a very good example for them to see, oh, my instructor is not just teaching it to me, but she's also using it herself. And also in teaching, we share, like in research, many of us talked about open research, sharing it with others, research findings, making it reproducible. But this is also the case for teaching as well. We share our course materials with others all the time. This, at the very minimum, can be our future self. We are sharing it with our future self, or we are sharing it with our TAs, our graders. If we co-teach a course, we share it with other instructors. And those of us who actually make it available online, we share it with the general public, other instructors around the world as well. So just like we care about reproducibility in research, we should also care about reproducibility in teaching for these reasons. So one of the things we proposed in the paper was the framework for reproducible teaching, and all teaching materials we said should be computationally reproducible. They should be well documented and also open. So we'll dive into these three principles of reproducible teaching with what you have seen probably from research perspective, but with examples from teaching. I'll talk about computational reproducibility, and then Mine will take over and talk about documentation as well as openness. So when we talk about computational reproducibility from teaching perspective, of course, we also consider literate programming as part of this. Since other people have said a lot about literate programming, I'll say this from teaching perspective. So we have in the past have used R Markdown for this, and currently we have switched to Quarto. But everything we say about research, having text, code, we also, at the same time, this is also important for teaching as well. We do use text, we do use code in teaching, so why not merge them all in one document? Some examples might include course websites. Some of us actually design course websites, make these publicly accessible. And for instance, here I have my introductory data science course website, and this course website is written in Quarto. And if I had to incorporate NR code into it, I can easily. This is another example of how literate programming can come up in teaching is when we prepare our slides. This is an example from Mine's data visualization course. If you consider about types of slides we make in our courses, in some of our courses, we teach R, and our code and our slide text actually can live in one document at the same time. And another example, I wanted to give this example because I think so far, perhaps some of the audience members might be thinking we should use reproducibility when we have code and text. Actually, in this example, I have an example from my introductory statistics course, which with the probability example, in this course, I don't actually teach R that much. My students use R, they use it pretty much like a calculator, but I don't go into explaining, like having them think about functions or arguments, but this is more of like using R, like teaching with R versus teaching R. So in this course, I'm actually just teaching with R. My idea is not necessarily make them become like advanced R users. But for this course also, I always use R for my materials, and here's an example. So even if we are thinking about courses that are more traditional, that are not more web-based, but more like PDF-based courses and more probability, more theoretical courses, even if the students are not learning R in these courses, as an instructor, we could still consider reproducibility for the instructor, even if not for the student. Another thing that reproducibility comes a lot in teaching is data. So I think now pretty much any guidelines tell us to use real data. And one aspect of finding real data, especially out in the wild, is that it's not always clean. So this job can fall onto the instructor to clean or even give it the shape that they want the students to have. So it could be smaller, a sample of that data set. But just like we think about this from research perspectives, the same principle goes into teaching perspective as well. Always keeping raw data as raw data, and then having a cleaning script before we get to that nice teaching clean data example. Another type of data that shows a lot in our classrooms is simulated data. And perhaps from a reproducibility perspective, one thing that becomes very important in that case is setting seed. And setting seed is not just important for the instructor reproducibility, for like trying it for ourselves, but also it becomes very important in a greater picture that we will see very soon, how it relates to version control as well. Another thing that comes in our computational reproducibility in teaching is file organization. Actually, File organization, perhaps naming things in files, where files are stored, it can or cannot be related to reproducibility, but it does for sure makes reproducibility a lot easier. So some good principles might be, one thing we rely on a lot is using a project-based workflow. This really avoids us from having to change file paths from TA's files to our files and so forth. And if you share it with other people too, so they don't have to change their file path if they use project-based. Another principle coming from Jenny Bryan is file names being machine readable, human readable, and playing well with default ordering. So we have one example on the left showing a typical work week for students' and this is usually prepared by the instructor. You might have different workflow too. Maybe you might give quizzes in a separate folder. You might give, and it might have every week in it and so forth. But this is just one example of what file organization might look like. So we have week 11 simple linear regression. So this first and foremost tells the student where in the quarter we are. We are in week 11. So there's this ordering. And we also know that this is not just an untitled set of documents. This actually is a theme of simple linear regression. Another thing that might be important in this example is that within this project folder, we have data, lectures, and quizzes. So if we looked at quizzes, in addition to using quiz 11 to indicate the 11th week, we also have ABC lettering to show the default ordering. So unfortunately, if this course was Monday, Wednesday, Friday, MWF would not have been a good default ordering because W comes after F, same with F comes first, FMW, so that would not have made a good sequence. But ABC really shows the student the order of documents very well. Another thing that can help us with file organization is using the here function within R. For those of us who teach with R, we rely on this a lot too. This really sets the file path to the root of the project. We don't really have to care about what type of file we are in, what kind of code we're running, where is the root directory, and so forth. The root directly goes to the project. And we've talked a lot about version control. There's this really nice quote by Jenny Bryan: "Collaboration is the most compelling reason to manage a project with Git and GitHub. My definition of collaboration includes hands-on participation by multiple people, including your past and future self. That is, the past instructor and the future instructor, as well as a symmetric model in which some people are active makers and the others only read and review." I think this holds true for research, software development, teaching as well. So we use version control in our teaching as well. A very good example that I wanted to mention about StatSeed is here. So if we were an instructor who just relied on making slides in PowerPoint, and if we had generated code, simulated data using code, and then moved this to PowerPoint, let's say, or any slide software, without having a reproducible workflow, we might have missed this. So from our versions 3 to 4, the random seed has changed in R, which made changes to the numbers generated as well. But the fact that we were able to use version control and see slides changing from one term to the next as the R version has changed, we could really see the simulated data changing as the version of R has changed as well. And for those of us who are teaching with GitHub, a useful resource is GitHub Classroom. They provide a lot of benefits, makes things a little bit easier for course management as well for anyone who might be interested. And I'll hand over to Mine at this point.
Yeah. And share. Right. So I'll pick things up here and talk about documentation. So first and foremost, data documentation. Mina talked about the importance of keeping data as raw data and then including a cleaning script and also the clean data or reshaped data that you might be using for your lesson. In addition to this, it's important to also document the contents and provenance of data files. An option could be a single README file with variable descriptions and the data provenance that's saved alongside a data file. For me as an instructor, there's nothing more frustrating than coming across a colleague's data set that they may have found to highlight a statistical concept, for example, that works really well. But I have no idea if it's real or not, or if it's been altered in any way because I don't readily have accessible the provenance of the data. So this is to avoid that a little bit. Another option would be to, especially for data sets with lots and lots of variables, to include a CSV file with variable descriptions. And if you name them as like name and description, it becomes also possible to load these as a separate file into R or whatever environment you're doing the coding in, and rename the variables if you need to, for example, and then a plain text file with data provenance as well. Now, I keep saying plain text, and this is sort of continuing from Mina's comments on version control. If your teaching materials are going to be version controlled, it's really important to avoid rich text formats like Excel or Google Sheets or Microsoft Word, so that the files are version controlled as well. Folder documentation is also really important. We recommend including a plain text README file in your overall course folder, as well as each top-level subfolder that explains the folder's contents and outlining any steps to reproduce the materials. Like you might say, in order to create my course website, grab this folder and run Corto render. So this is what a course folder might look like. This is usually what my course folders look like, where there's a top-level README and then separate folders for things like slides, labs, or any data sets. And then you can see that those are additionally documented in the hierarchy as well. Software documentation is also very important, and this is where things start to get a little bit tricky. At a minimum, it's really important to document versions of R, Corto, any packages that you might be using, using README files that might be manually updated. So you literally might type, as I'm, compiling these course materials, this is the R version R used. Or if you are creating this README file programmatically as a R Markdown or a Corto file, you can take advantage of the session info function in R. Now, the fact that you have documented it doesn't necessarily mean a year down the line when you have updated R, you're going to be easily able to switch back and reproduce that content. But if you are seeing differences, it is super helpful to see that a different version was being used. So it can start giving you hints. A medium level, if this is not part of your workflow but are willing to learn one tool using either RMV or VNV, depending on whether you're doing things with R or Python, to preserve the computational environment. I often find for myself that using RMV is super helpful until I get really frustrated. Some things fall out of sync, and then I might be spending a bunch of time troubleshooting, perhaps right before a lecture, and get frustrated. But in the long run, I never have found it to be a bad idea. Just at times, small frustrations come up. And if you are a more advanced software user or a software builder yourself, you might be familiar with building Docker containers for yourself, where you can really do a full environment snapshot. As you go up the ladder in this software documentation, it becomes a little bit like what they say about using regular expressions to solve problems. Now you have two problems, but it is also, if you are doing it well, not a bad idea. And I personally find that sometimes as an instructor who is often assigned to teach similar courses from semester to semester, it's these little forays into new tooling that actually keeps my brain fresh as well. So, and keeps me humble alongside my students who are learning new things. I'm learning new things as well. Another thing we would strongly recommend is to think beyond the generation of your static course materials, but think about reproducibility in your communication with students. I'm sure we've all been frustrated ourselves if particularly you're using something like an online discussion forum where students say something like, it's giving me an error. I don't know what's wrong. And oftentimes we ask them, can you describe it to me? Maybe can you provide a minimal reproducible example? The reprex package is really helpful for generating reproducible code snippets and sharing session details when answering student questions. And as a fan of this package, I will, before I give you an example, say that this is not to say that on day one of learning R, you should also try to teach your students to use this package, because building minimal reproducible examples is actually a pretty difficult task. But you being disciplined to use it in your answers to the questions can motivate them to try to sort of think about using these tools as they ask questions as well. So how does that work? Say you have a code snippet, something like I have two vectors of different lengths and I'm trying to add them, and R does its funny thing of recycling if the length of one is a multiple of the other. And this could be confusing for a student, where if the length wasn't a multiple, you would get an error instead. So you write the code and then you highlight the code and either run reprex, or you can use, if you're in RStudio, for example, use the add-in to do that using the GUI, and it will create a snippet that is then stored on your clipboard that you can paste into whatever discussion forum you're typing on. As you can see, the snippet is nicely formatted where the code lines are not commented, but the output is. So if a student is haphazardly copying the whole thing and pasting it into their environment, they won't accidentally try to run the output since that's commented out, and they will just run the code. So you are enabling your students to sort of like run code that you have generated to help them. And also, I find that as an instructor, it keeps me honest when answering questions, because I'm never doing, oh, I think this should work, because oftentimes it doesn't, and it's my memory serving me wrong. Next, let's talk a little bit about code style. So I'm going to show you three options. Here is a line of code for fitting a linear regression. Here's another one, the same functionality formatted a little bit differently. What's your style? Option one or option two? Or better yet, or worse yet, are you in camp option three? Who cares? It doesn't really matter. The code would run either way. Now, we refer to this as code style, and the word style, might also come up in your life in avenues like fashion. And when it comes to that, I fully agree. There is no right answer. It's whatever your heart desires. But when it comes to code style, that is not the case. I would argue here that option two is superior to either option one or option three. And in fact, option three, inconsistency in the style you present to students, whether in communication or in your materials, might then make it hard for you to ask for consistency from them. So showcasing a consistent code style that is easier to read. I often think about it as haikus as opposed to novellas. So we want a lot of line breaks. Can make it easier for them to read, and also easier to catch errors. So importantly, pick a style, any reasonable style. So I wouldn't necessarily say any style, but any reasonable style. And at a minimum, avoid things like spaces, use line breaks to improve human and machine readability. And ideally, conform to established professional style guide for better student preparedness. So for example, the Tidyverse style guide that is also adopted by Google as well is a great style guide, whether you teach with the Tidyverse or not. A lot of the principles apply to writing code in R and placing line breaks after each function argument, for example, particularly for long lines. Similarly, there's Google's Python style guide or a Julia style guide. So whatever language you're teaching with, dive into that community, dive into the best practices of that community, and pick a style guide and stick to that as much as possible. And also use that in all of your course materials. We've talked about documentation. Now let's turn our attention to openness. And it's wonderful to be in this session where we've heard a lot about openness. And I'll be very honest for a second. When I saw that acronym FORT, I was like, oh, I'm never good at coming up with good acronyms for my projects, but I really liked it. So the gold standard for openness is to openly share materials on publicly hosted websites to increase accessibility and reusability. It's a challenge that comes here. There may be policies, university policies on hosting course materials in password protected learning management systems, which would provide consistency for students across courses, but it does end up limiting broader access. So, how might you go around this? If you are in an environment where this is a requirement professionally for you, consider posting your materials both on university platforms for students and publicly for wider access. The open access benefits learners worldwide, and open source sharing allows other educators to adapt and reuse your materials as well. And frankly, if you are doing this with um, current tooling that creates better looking of the same era websites, I think you will find that your students actually gravitate to your public website as opposed to a learning management system that might be highlighting the best in web design in 1995 before they were even born. When you are sharing openly, though, licensing is always important. So always release your materials with a license, whether they're open access or open source. For non-software materials, consider whether to allow derivative works and how they can be reshared. So Creative Commons licenses are helpful there, and consider other licenses for software. This often is a new foray for a lot of educators. So I would recommend, we have a recommended reading in our paper that I might recommend if you're not familiar with it, that you look into in terms of choosing the right license for your materials. So, in wrapping things up, I'd like to point you to an example. This was from my course last fall. Mina and I share a lot of sort of common practices and workflows. So we just picked one of the courses. So this is what the course website that students see and others in the world see look like. You're welcome to go ahead and visit the website as well. And what you'll find is that on the back end, a GitHub repo is serving this that's being generated with continuous integration. And at a minimum, I've highlighted one of the good practices that we highlighted. There's a README in the course repository that gives others instructions on how to render the course website, as well as how things are being published and how the computational environment is being managed. So another colleague who may want to borrow pieces or the whole course has some instructions for getting started. To wrap things up, let's talk a little bit about challenges and benefits. First of all, rarely, if ever, an investment in reproducibility doesn't pay off. It could be a colleague thanking you, it could be yourself thanking you the next time you're assigned to teach the same course. But adopting the full framework that we've presented likely requires learning new tools, and importantly, keeping your and your co-instructors and your teaching assistants' knowledge of tools and ecosystems up to date. And I will be the first to admit that this is no small feat for a busy academic who's already doing a million things at once. It can be enjoyable, but it is true that it is a time investment. And finally, openness brings free learning materials to your discipline and community. It often invites kudos from colleagues using your materials, which is the nicest type of email to receive at times. And it generates opportunities for collaboration and recognition. Mina and I found each other not because we have the same name, but because we share our materials and often can see, opportunities for collaboration as well. And finally, it can serve as a role model for your students. We heard earlier how it can be challenging to promote reproducibility when students are learning. I think it's even harder when you are not using the same good practices that you are recommending to your students. I'd also like to end with a nod to Mina's new paper on the same topic that's on the annual review of statistics and its application. So if you enjoy this content and the earlier paper, this would be a good one to refer to as well with some of the updated guidance we've presented here. And you can find us on a variety of places, as well as the slides and the source code for them at the link here. Thank you very much. Take a look to see if we have
Sorry.
any.
Yes, I don't think so at the moment. So, but perhaps some are going to come in right now. But I've got many, but I'll just keep it to one for starters. So I do a lot of what you're talking about when I'm teaching statistics, and the students often like view my code on GitHub. And I find it particularly useful to teach them about the importance of things like using here rather than setting the path name and so on, because they can't run my code if I've got path names that are specific to my computer. Anyway, so my question was, are students are they all viewing the source code up on GitHub, or is it primarily there for you and your collaborators and your future self and so on? So I was just wondering about like how students are using these materials kind of as they're being taught.
I'll say that for particularly my introductory data science course, but really for all of them, that is not the expectation. What they are learning or expected to learn is presented to them in snippets at bits that they should be learning. But something wonderful that tends to happen is when students are working on open-ended projects towards the end of the semester, I'll get questions like, I remember that one
Yeah,
plot you showed us.
yeah,
Like, how
yeah,
did you do that? And I can
yeah,
often be like, oh, go to the source code so
yeah,
they
yeah,
can benefit from it. But the expectation is not that they're regenerating that material.
yeah, absolutely. Okay. Um, so if anybody has any other question, and you're not able to type it at the moment, I mean, if you want to just raise your hand, and please feel free at this point, or put it in the chat or whatever. Okay, I don't think so. So in that case, unless if there's any other questions, if anybody has any other questions for any other speakers, too, let us know. But it doesn't look like it. So in that case, I think we should come to an end. We are bang on time, just 1 minute to 5 p.m. UK time. So good timing.